We are the full stack force. We have Ruochi, Ziyu, Xiaoyao, and Pavisha. Our project is a network painting application developed using D language, and we are excited to show you a live demo of our work. Our application allows multiple users to paint at the same time and choose different colors and brushes to paint. Even if the network connection is closed, a user can still be able to paint. The extra feature we developed is painting brush. You will get a chance to see all 4 of our brushes in action during our live demo, and my teammate will also walk you through some of the code.
Hi, so we're here to demo about our Collab Paint application and walk you through some code. So first, I've executed dub run, and when we run our project, it asks whether you're a server or a client. So I first launched the server, and the server started, and then another terminal, I've again run dub run and given the client command, and the same local IP address and the port number to launch another client, and same for the second client also. So now we have 2 SDL apps launched as the result. So when I draw something in one client, it gets reflected on the other client also. So if I now launch a third client, ideally whatever drawing I did before should also be visible for the third client, which is the case here also. So that's good. And we have different colors and brushes that will be explained later. So when we press U on the keyboard, it undoes the operation. When we press R on the keyboard, it redoes the operation. And we've made it a design choice that only a particular client can undo and redo their own actions and be reflected for other clients, but I cannot undo something another client did. So now let's walk through some code for the networking part.
So in our app.d file, we run 2 threads for our client port. In our main thread, we keep our SDL app running, and we spawn a new thread for listening to the socket server. So like every time we are drawing on our canvas, we send a packet of a type update to our socket server. So the packet will contain like all of our pixel information and with a message update. And the other kind of packet we will send to the server is like when we quit our SDL app, then we will send a packet with dummy data and with a message quit. Then on our server side, we will react differently, like depending on the packet message. So if the packet message is update, we will insert the packet to our list of history packets, and then we will send this packet to every other client connected to the server. And if the packet message is quit, then we will send the quit packet back to the client and remove the client from our connected list. And also, like when a new client joins, then we will send all of the packets in our history packet so that the new client can also receive the canvas with our previous drawing. And in our client listener code, so this is where we wait for the socket servers to send packets to us. So when we receive an update packet, we know that we need to update our screen. So we draw out the packet's information on our surface. And then when we receive a quit packet, then we know that we can stop listening to the server and terminate our client thread.
As we can see from the painting canvas, there are 2 panels. The first one is a color panel, and the second one is the brush size and type panels. The user can click the colors to choose which color they want. And here's how we implemented our color panels. We created several colors at first, and then we iterated each color so we can print out the colors at the painting canvas. And for the brush size, we actually have 4 of them at first, and we have several methods to check. First one is click inside the brush panels to check whether the user clicked inside of the brush panel, and then we have this method to get the brush size from this panel. And to use these functions, we actually implemented in the SDL app. So when the user click the mouse, you will check whether if it's inside the brush panels, and if it is, then we can get a brush size from the panel. And for the extra features, we did include the brush type. So we split the brush size into 3 types, which are small, medium, and large. And we've implemented the code here. So when we click the small, it will actually do like the regular one, and if we do the medium, it will be a little bit wider, and if we do the large, then it will be actually the double lines right here. So that's how we implement it.
We have a unit test to ensure that the program initializes the surface correctly, displays the correct brush types, drops the panel accurately, and connects the client and server networking seamlessly. If you are interested, you can run the dub test to see the result. Moving forward, we have plans to add a drop-down menu to display more color options, and we are even considering developing a chatting feature. But for now, we are excited to share our current progress with you all.